Alright, let's look at a few more indeterminate forms. Alright, let's look at the third one. Alright, 0 over 0. Alright, so if you look at this limit, number 55, as x approaches 0 from the right hand side, so the base approaches 0. Of course, square root of x also approaches 0. Alright, so we can, this is one of these forms. So we can rewrite this guy as limit as x approaches 0 from the right hand side. Then we can write it as e to the natural log of x to the square root of x. Right? So we can use the natural log of property to place square root of x in front. Right? So we can do is also, since the exponential function is continuous, we can put the limit inside the exponential function. So we have a e to the limit as x approaches 0 from the right hand side. And then we're going to put square root of x in front. But better yet, I'm going to actually write it as 1 over square root of x, which is x to the negative 1/2 power. Then you have natural log of x. Right, so we have that. Alright, then you can see that as x approaches 0, natural log of x approaches negative infinity. Right, as x approaches 0, this is basically 1 over square root of x. This guy approaches actually infinity. Right, so we have infinity over infinity situation. So we can apply L'Hopital's rule. So by applying L'Hopital's rule, we have e to the limit as x approaches 0 from the right hand side. Right, then you would have, right, so derivative of natural log would be 1 over x, and derivative of x to the negative 1/2 power is negative 1/2 in front, x to the negative 3/2 power. Right, so we can clean this up a little bit. So if you multiply top and bottom by, because I don't like to have negative power here, so I'm going to multiply by, say, negative 2 x to the 3/2 power. So I'm going to multiply top by the same thing, negative 2 x to the 3/2 power. Right, so you can see that negative 1/2 and the negative 2 cancel out, and the x to the negative 3/2 cancel out with x to the 3/2. And if you simplify that, you're going to get this. You have e to the limit as x approaches 0 from the positive side. Right, so it's going to be, so bottom is 1, the top is negative 2, right, and so it's going to be x to the 1/2, so just the square root of x then. Right, so as x approaches 0, this guy approaches 0, so therefore you end up with e to the 0, which is 1. Right, so that's the limit. Right, how about the next one? If you have infinity over 0, right, so you can see that as x approaches infinity, the base approaches infinity, but the power approaches 1 over infinity, so approaches 0. Right, so we can actually use exactly the same trick. So we can write it as limit as x approaches infinity, e to the natural log of x to the 1 over x power. Right, then again, we can place this power in front of the log using one of the log properties. So we have, right, and also I'm going to squeeze the limit inside the exponential function. So e to the limit as x approaches infinity. Right, so this is just going to be a natural log of x over x, because it's a 1 over x. right? Then we have, this is natural log of infinity is infinity, x is going to infinity. So you have infinity over infinity situation, so we can apply L'Hopital's rule. Alright, so you have e to the limit as x approaches infinity. So the derivative of a natural log of x is 1 over x, and derivative of x is 1. Right? Then as x approaches infinity, 1 over x goes to 0. So again, this one is also going to e to the 0, because 1 over infinity is 0. So again, the limit is 1. Alright, so let's look at the last example. What if you have 1 to the infinity? Alright, so the trick is actually exactly the same. So we write it as a limit as x approaches infinity, right, e to the natural log of 1 plus 2 over x raised to the x power. Right, so we can place it in front. So we have, right, and squeeze the limit. So e to the limit as x approaches infinity, right? And also multiplying by x is equivalent to divide by 1 over x. Right, so you have a natural log of 1 plus 2 over x. Right, so as x approaches infinity, right, so you have, let's see, as x approaches infinity, 1 over x, let's see, 2 over x, this approaches 0. So you have a natural log of 1. So natural log of 1 is actually 0. So this guy approaches 0. Right, and also here 1 over infinity, so this guy approaches 0. Right, so we can use L'Hopital's rule there. Right, so L'Hopital's rule. Right, so you have a e to the limit as x approaches infinity. Right, so derivative of that is 1 over 2 over x on the bottom. Alright, take the derivative of that on top, so it's going to be negative 2 over x squared. Right, then derivative 1 over x is negative 1 over x squared. Right, then we can cancel negative 1 over x squared, so negative 1 over x squared there. Right, then as x approaches infinity, this guy actually goes to 0. So what's left is actually 2 over 1, so it's 2. So therefore, you have e to the 2, which is the limit. Alright, that's it. I hope that this was clear.